Hello everyone. Good evening. Welcome to Dr. Ravi's Academy. In today's class, engineering mechanics class, we will be learning the applications of Varignon theorem by means of a problem. That problem number is 7. So let us look at the problem. For the truss shown in figure, a truss is given and is asking compute the perpendicular distance from point E. So this is one point, and from point G another point. So he is asking the perpendicular distances from line joining B and D. So this is the problem. So in this you can see that purely is asking the moment arms. So to determine the moment arms, we are selecting the point E as moment center. We are treating that it is case 1, and we are selecting G as moment center, and we are writing the Varignon theorem. So we are considering E and G as moment centers, and we are writing the expression for the moment of a force, and we are assuming that a force is acting from B to D. So let us consider case 1. Or case 1 is here it is you want to find out from point E. So it is let us consider the perpendicular distance, that is D1 from point E, and the other side case 2, that is we are considering the perpendicular distance, that is momentum from point G. We are considering this as D2. The distance is D2. So let us assume that a force is acting from B to D. So I am indicating a force P is acting along the line joining B and D, and this is a resultant force. Let us form a rectangle with the BD as a diagonal, and you can resolute that into two components. So this P, let us say this is alpha, P cos alpha, and the vertical component is P sin alpha. So here the dimensions are given. Let us look at the truss. The span, the length between the two pin joints is 12 meters, and the height it is given 12 meters, 16 meters, and 18 meters. Of course, it is symmetric. The truss is symmetric about the vertical axis, and this length, if you join these, this length is it is 16 minus 12, that is 4. So this length is 4 meters, and the span between these two is given, it is 12 meters. So your alpha is equals to, it is tan inverse of 4 by 12, that is tan inverse of 1 by 3, and you are going to get 18.4 degrees. Alpha value is 18.4 degrees, and the moment you know the alpha, divide that into two rectangular components and make use of the Varignon theorem, and let us write the moment sum of and you are erecting a perpendicular to passing through this particular point. I am calling this as D1. So this is 90 degrees. Let us write the expression for moment of force P. I am using a symbol moment of force P about the point E is nothing but it is P, the resultant force, into the momentum D1. So this you can write down as the algebraic sum of moment of its components. It is P cos alpha is the horizontal component, and this is the line of action, and momentum is 12 meters. This is 12 meters plus the vertical component P sin alpha into, this is the line of action of the force, and you can see that this length is 12 meters. So this is also 12, and let us rewrite P into D1 is equals to 12, and P you can take it as a 12P outside. You can write down it is cos alpha. Alpha is 18.4, cos 18.4 plus sin 18.4, and of course P gets cancelled, and D1 value is 12 cos 18 plus sin 18 degrees, 18.4 degrees, right? And if you simplify this, you are going to get it is 15.2 meters. This is the answer. So the distance between point E and the line joining BD is 15.2 meters. So this is case 1. Now let us look at the case 2. He has changed the point. He is asking about G. So let us extend the force you are assuming same. Let us extend it, and he is asking this particular distance. It is perpendicular distance. Let us call it as D2 with the moment center as G. You are writing the moments, and for the same force the components remain same, and that is P cos alpha and P sin alpha. Only changes you have changed the moment center from E to G. Now it is the moment of force P about G is, it is P multiplied by, it is D2, that is P is the resultant force and D2 is the perpendicular distance, is equals to its component forces P cos 18.4. This is the horizontal component, and it is about this, the moment arm is this distance, that is nothing but 12 meters. So the moment arm is 12 meters plus P sine 18.4 into the moment arm. Observe carefully about this point. Here the component is here, this distance is 12 plus 12, that is 24. Your moment arm is 24. Now you can rewrite it is a P into dt. D2 is equals to, you can take a 12P outside. Now you have cos 18.4 plus, it is 2 sine 18.4. So this is the left of P gets cancelled, of course, and you have D2 is equals to 12 into cos 18.4 plus 2 sine 18.4, and if you calculate using your scientific calculator, you are going to get a D2 value as 19 meters. So this is the answer. So now we have learned how to make use of this Varignone's theorem to determine the perpendicular distances, that is nothing but moment arm. Thank you for watching this video. Thank you.